Let us now review the slab strip diagram in the FE model. Zoom to the beam slab model. Recall that we have created span strips X1 and Y1. Under slab strips diagrams, select strip X1. The design moment of the strip will be shown along the strip X1. This maximum positive and negative design moment is calculated based on all the results of the FE slab shells. The gray nodes are additional lateral or traverse nodes that are calculated to offer greater precision, as the slab shell nodes may not be sufficient if the slab mesh is large. Results collection method. Maximum. The maximum of the lateral or traverse nodes at each station is used. Strip line only displays the values at the station nodes, and lateral nodes are not considered. MD is design moment, which has included the wood armor effects. Wood and armor is an analysis method that explicitly incorporate twisting moments into slab design contours. It is recommended to always refer to MD plots that include wood and armor adjustment, as these will always be higher than the unadjusted moment. This is evident by comparing the two design diagrams. For more details, you can refer to this reference Wood, R.H., 1968. The reinforcement of slabs in accordance with a predetermined field of moments. Currently, we are looking at strip diagram of load case G. We can look at combination 2, example factor G and Q, and other load combinations. It is more meaningful to look at envelope diagrams, as it is a superimposition of all load combinations, as these will be used in the final rebar strip design. Specifically, envelope minimum will superimpose all combinations results, and just how the hogging, negative moments. Conversely, maximum envelope will superimpose all combinations, and just show the maximum sagging positive moments. You may proceed to display Y1 strip result. Let us zoom in and look at the flat slab model. Next to slab strip, choose X2, which is the horizontal fixed band strip we cut through the slab. Notice that lateral or traverse gray nodes are shown for the entire extent of the strip width. This is expected of fixed band strip, where all nodes within the strip length and width will be considered. Results collection method. The maximum in strip line is the same as previously. Integral option is only available for fixed band strip. As explained previously, this will average the design moments along the lateral nodes. This will result in lower design moment as compared with maximum method. Integral option will only be used in design if it is specifically chosen in the slab strip properties, else it's just for viewing purpose here. You can choose Y2 to look at the diagram of the vertical strip. Investigate both minimum envelope and maximum envelope. Go to the Contours tab. This is where we can interrogate the slab analysis and design diagrams in more detail. Take note that this part is not compulsory. If you have already created the slab strips and just want to go straight to design, we can skip this part. Click Contours. The effects pane will appear, where there are options to show displacement, forces, bending moments, and required steel area contours. You can resize the effects pane to expose more text. To create a bigger viewing screen, click on the filter pin to hide it. Let's examine the displacement contour. Click on displacement C and load combination G plus Q. The legend is with reference to the global coordinate system, as shown at the bottom left. Hence displacement C is out of the plane of the slab.
F11 and F22 is direct membrane force. F12 is shearing membrane force. V13 and V23 is out of plane shear force. Bending moment in local direction. M1 and M2 is the bending moment in local direction 1 and 2 respectively. M12 is the twisting or torsional moment due to the wood armor effect.
Design moments, wood armor. These are design moments with wood armor torsional moments included. From the design moments, the required steel are calculated. There are 4 contours, due to 2 directions, top and bottom steel. For example, a S1 bottom will show only the bottom required steel in direction 1. The rest of the values is set to 0. Required steel areas with wood armor effects included are marked by extra D, example ASD1, bottom. We recommend you always use the ASD contours, as the values will always be higher than the AS contours. The rest of the icons are discussed in more detail in Prota Help Center and in Flat Slab Design Guide. Click on the Story 1 Plan View. We can design the slabs now. Go to Design tab, click Slab Analysis and Design. The Slab Analysis and Design dialog will appear with a summary of slab strip design, such as type, Utilization ratio, design status and rebars. The design status is shown as red cross, and there is no rebars stated as design has not been performed. Before design, let's click Settings and Parameters. The slab settings will appear. In the Design tab are options such as support bar extension lengths, parameters, and others. Slab design combinations. There is choice to use all combinations including lateral combinations, or simply vertical or gravity combinations. Column node interpretation. There are 3 choices. Include column node results. All results from all nodal points, including column peak center nodes, will be considered for the design of the slab. All green nodes shown in the diagram are included. This will result in the highest design value amongst the 3 options. Ignore column node results. Column center node will be ignored, and the results from the adjacent node will be used. Red node, that is the column center node, is ignored. This will result in lowest design value amongst the 3 options. Average with nearest node results. The results are obtained by taking an average from the peak center node and the neighboring nodes. The red column center node is ignored. The smaller, interpolated green dots between nodal points are used. This will result in approximately intermediate design value amongst the 3 options. Wood armor effects in design. Let's choose Include, instead of Ignore, for reason already discussed. Go to Rebars tab. Take note we will use the default H10 for minimum bar size. Further, will be accept the minimum and maximum bar spacing and bar spacing step, etc. Appearance controls the graphical presentations such as show steel bar total length, span lines, etc. Click OK to exit the dialog. Let us design slab strip X1. Select the slab strip by clicking on it. Click Interactive Design. The table shows the summary of the slab properties and design results, including the rebar. Click Design to design the slab strip.
The standard 3 options will be shown. Since this is the first design, it will always default to the last option, reselect all bars.
The design results and rebar information will be populated. Notice the deflection check fails. You can click on the span rebar to change it. You can increase the bar size and decrease the spacing. Notice that deflection ratio L divided by D updates and improves, but the deflection still fails. This means if deflection is a real concern, then the slab thickness should be increased. Click Strip Profile. This will show the envelope bending moment diagram and deflection by default. You may choose a load case or load combination to view, if desired. Click Exit to close it. Click Report to generate the design report for this slab strip. Review the report. Close it. Click OK to close the interactive design. Only X1 slab strip is designed.
Design status still show fails because deflection check fails.
Click Slab Strip Design, Batch Mode, to design all slab strips in one go. The standard 3 option to batch check or redesign are available. Choose the last option and click Design to redesign all fresh. Click Close.
Inspect slab strip Y1 for the beam slab model. Similarly, it fails in deflection. The only way is to increase the slab depth, as increasing the rebars does not solve the issue. Fixed band strip X2 and Y2 is for the flat slab. Inspect the results. It passes because the slab depth is thicker and the designed rebars are larger.
Filter. Allows filter by story, slab thickness and design status. Click Cancel. Copy bars and paste bars. Allow copy and paste bars of similar slabs marked with equal symbol. First select the slab strip, then click Copy bars. You can then select another slab strip with equal sign and paste it. Only slab strips with the exact slab configurations and direction can be copied and pasted. Click Design Report. Entire slab reinforcement design report of all slab strip can be generated, provided the box under Print is checked. If not, click Mark all slab strips before generating the report. Any failure in the design will be highlighted in the notifications pane at the left. Review the report and then close it. To summarize, the deflection check fails for X1 and Y1. In order to achieve all pass, we need to increase the slab thickness. Close the dialog box. As shown on plan view, only slab strips that pass will have the reinforcement shown.
To summarize, for the beam slab model, we have used finite element span strip. This designs the top rebars over the support and bottom steel over the span. For the flat slab model, we have used finite element fixed band strip. This designs a single top and bottom steel, derived from the maximum hogging and sagging moment, within the entire extent of the strip. Next, for flat slab model, we need to perform punching shear check for the column. This can be done by selecting the columns, and click punching check icon. Kindly refer to Prota Help Center for more details.
Go to Drawings and Reports. Click Form Plans to generate a preview of the drawings. Click OK. A form plan view will be generated. In order to produce a DWG or DXF file, we need to go to Prota Details.